I'm Fred Grocock, Chair of the IADC Technical Publications Committee, or TPC, welcoming you to our video podcast, Drilling In, about Mark Ramsey's book, Practical Wellbore Hydraulics and Hole Cleaning, which was published by Elsevier back in January of 2019. But first, a word about the TPC. This committee was formed more than 20 years ago for the purpose of writing, compiling, and publishing books on drilling oil and gas wells. Since then, its mission has been expanded beyond oil and gas. Originally, this was intended to be like an encyclopedia of drilling, but now its mission is to create a comprehensive, practical, and readily understandable series of peer-reviewed publications on well construction and integrity in the energy industry, to educate personnel at all levels. Now, these books are written by well-known and highly respected experts in their fields. Before being reviewed and edited by Elsevier, who is the premier publisher of scholarly books on the latest technologies, our books are first reviewed by members of the TPC, all respected engineers and scientists. The 60-member TPC, in fact, has published now 11 books. Before we start the interview, just a few words about the author. Mark S. Ramsey is the head of Texas Drilling Associates, a consulting engineering company that provides well planning, rig team training, execution, accident investigations, research and product development, and product launch services for the oil industry worldwide. He authors and teaches both introductory and advanced drilling courses on 6 continents, including a Master of Science level drilling course. Now, Mark earned a Bachelor of Science in Mechanical Engineering degree from Texas Tech University, who honored him in 2016 as one of their distinguished engineers, an honor bestowed on less than 0.05% of their graduates. That's 1 out of 2,000. He's a registered professional engineer in the state of Texas, too. Now, previously, Mark worked for Exxon in drilling research and operations and was named an Exxon Distinguished Instructor. While at Exxon, he also created and is credited with numerous inventions and techniques mostly related to downhole drilling tools and procedures. In addition to this book on hydraulics and hole cleaning, he authored the initial drilling portion of Schlumberger's highly utilized online glossary. And he helped Amoco, the company I worked for, produce and deliver the highly successful Training to Reduce Unscheduled Events, or TRUE training, and the related handbook. And now for the interview. Perhaps, in fact, we should take a walk through the book before we launch into any specifics. So tell us about practical wellbore hydraulics and hole cleaning.
Okay, well, thank you very much, Fred. I've got kind of thought about how to present this in a quick way, and the first is just to kind of mention that the chapters in the book are mostly standalone chapters, i.e. if you were only trying to size bit nozzles, you could read the chapter on bit hydraulics and wouldn't have to necessarily read the rest of the book. Same thing with hole cleaning, same thing with some of the other chapters. But the chapters themselves are pretty straightforward. I'll tell you a little bit about our focus in just a moment, but first there's an introductory chapter. It's a short chapter, kind of ties everything together for the rest of the book, lets you know what to expect. Then there's a chapter on bit hydraulics, and that very specifically is looking at how you properly size bit nozzles to optimize your hydraulics. And notice I didn't say maximize your hydraulics, but optimize those hydraulics. The third chapter is on hole cleaning. So just in those first 3 chapters, we've essentially covered the title of the book, Practical Hydraulics and Hole Cleaning. And then after that, there's some other chapters in interest certainly to the engineers and probably most of the field personnel. One of them is what do these optimization effects have on the efficiency of the overall drilling operation? Are we actually just drilling more efficiently if we do this optimization? There's a full chapter that kind of pulls into one place all the various equations related to bit pressure drops, annular pressure drops, pipe pressure drops that you might find scattered in SPE papers all throughout the industry, and it kind of pulls it all together in one handy chapter. Let's say if you were going to write a modeling program of some sort. You've kind of got all the reference equations right there together. And then last, we've got a chapter on fluids themselves, on the drilling fluids, on rheologies, how that in turn affects these optimizations. After that, we've got a couple of smaller chapters that deal with things such as how the mud properties change from the surface as you circulate the mud downhole or the drilling fluid. And unfortunately, what we measure on the surface is not what happens downhole, particularly across the bit, which is one of our key things that we're trying to calculate. And then there's a small chapter on pumps. We have a lot of different pumps used in the oil field. We find out that most people don't completely understand how these pumps actually work, and so we were asked to add that chapter, and so we got a little chapter on that. The focus on the book, even though it's got multiple chapters, still remains practical bit hydraulics and hole cleaning. So those are the two major foci of the book. The other thing we did that's a little bit different approach than most books you may read is that if you're just looking for a quick answer, for example, you can go to that chapter, you can get a quick and dirty answer that gets you back on bottom drilling. If you want a little more knowledge of something, say just so you'll understand it a bit, there's usually a section in that chapter that extends the understanding, so you might do a little more complicated calculation the next time you plan the well. And then there's generally a third section that, again, if you're going to be doing some formal modeling or writing code or something like that to simulate the world, would be more appropriate for things like that. So quick answer, moderate understanding, full understanding is sort of the way we've approached that.
Wow, I mean, this sounds not only practical but also very comprehensive. Is that why you wrote the book?
We did. We were trying to pull together information, both new and some that had been published in the past, but in a way where both the rig personnel, the engineers in the office, and even scientists in the R&D groups, like you and I used to be, would kind of have all their needs satisfied all in one place.
So why now, though?
Why now? Well, I was asked to do it, and it wasn't actually now. It took about 10 years to get the book completely written and reviewed and to our liking, as you well know. But I was asked to do it, and then maybe my focus got even more on it as we get closer to retirement. We think, well, what are we going to pass along to the younger generation of drilling engineers and drill site personnel? And so we finally got it done. We're trying to pass along information to the younger generation who may not have had at least our experience yet.
A noble cause, to be sure.
Well, we try. We try.
So why do you think the book is important to drilling personnel?
Well, it turns out that the lifeblood of a drilling operation is the mud system, how the mud system is maintained, and how we use that mud system to clean the bit and to bring those cuttings that we've spent an enormous amount of money trying to crack rock, how we get those cuttings efficiently back to the surface. So ultimately, this is all about efficiently removing the rock back to the surface so we can remove more rock in an efficient manner. And all levels of drilling personnel need that, whether it's from the rig site or back in the office, either one.
Well, speaking of that, is there a preferred audience? I mean, somebody who would particularly benefit from the book?
There's actually a couple of different preferred audiences, and when I say preferred, we had them in mind writing the book. The first would be the drilling engineers, or perhaps a directional coordinator who's in charge of sizing bit nozzles to be compatible with downhole tools that maybe they are putting in for directional control or logging purposes. All these systems have to be compatible. So anybody that's going to be touching the art or the science of sizing the bit nozzles should get this book. For the rig site personnel, this unlocks some of the mystery as to why sometimes if they change the nozzle size, they don't get the intended results. And reading through this gives them an understanding of that. It also, if they just want a quick check on the nozzle sizes that came from some potentially green engineer back in the office, it gives them a quick way to do that.
What is different about this book compared to other books?
Well, that's a good question, Fred. I've thought about this a lot over the last several days, and first of all, we do put some new technology in this book that's been in various places over the past years, but it's never really been formally published in the way that we published it. Maybe starting with that, we tried to take a very, very practical approach to using the technology. Because if this technology is perfectly understood, but nobody's comfortable using it, it doesn't really do anybody any good.
For sure.
So we tried to do a very, very practical way of explaining things. And that's where we have some chapters, for example, that gives us the very quick and dirty answer that's acceptable for 80% of the wells. We also take a look at what happens when hydraulics are not optimized properly. And let's say you thought that running a particular nozzle size was okay in this whole section and never really gave it a lot of thought. And so you get ready to put a new bit in, you put the same nozzle size in, you get on bottom, you start drilling, and all of a sudden you realize that you've run out of pump pressure. And you're nowhere near the flow rate that you intended to run. Well, what caused that? It was the same nozzles you just took out of the previous bit. Well, we go into that kind of an issue. What happens when you get it wrong? As you deepen a well, two major influences come in that have never really been addressed directly in one book before. And that is that as you deepen the well, you're actually lengthening the fluid path that the mud has to travel. Well, that results in higher pressure at the surface. The second thing that generally happens at the same time is that, especially perhaps after a new bit is put in the hole, is we are raising the mud weight. And it turns out that raising the mud weight has a tremendous effect on that bit pressure drop. Mm-hmm. So if we tried to pump with the same nozzles at the previous rate, and the mud weight has been increased, then again, we would not be able to get maybe to the flow rate that we had intended in order to clean the hole. So we take a look at all of those kinds of things that's new. The other thing we do is we address something called pressure recovery. And this is a problem, probably more of a problem with tricone bits than it is for PDC bits. But it's present in both types of bits, and this was one of the things that serendipitously I found when I was asked to become a subject matter expert at Exxon. Found out that the equations that had been used for decades, literally at that point, were not accurate in predicting bit pressure drop.
Really?
And it led to a considerable amount of additional research paid for by Mother Exxon on why the results we were getting, both in the laboratory and the field and some downhole high-speed measurements, were not matching what the predictions were. And we finally got that all sorted out and presented that in a paper, but to my knowledge, it's never been actually put in a book. And to those of you that use just say an iPad or a phone application to calculate hydraulics, those sorts of things, most of those kind of software tools do not include this effect that we found that can be pretty significantly in error in calculating that bit pressure drop. Now today, if you're drilling a big, expensive deep water well, it may not be such a big issue because you normally have a pressure while drilling sub in the hole, and so you can calibrate what you're doing with that pressure while drilling sub. But for operations that may not be going to that expense, it can be a pretty important source of error that to correct for that particular thing.
Well, you mentioned several important additions, that are not present in other books. Any other new significant things?
Well, there is one thing, is that when I was in operations, we had a rig that we could infer how much power we were putting to various parts of the rig. For example, rotary table, hoisting equipment, pumps, those are typically the big three. And not all rigs are set up even today where you can easily monitor that, but we had this particular rig set up. And what we found is that if you don't have optimum hydraulics, and maybe we can talk about this a little bit more later, but if you don't have optimized hydraulics, it turns out that you will be burning a tremendous excess amount of diesel fuel compared to if you are optimizing hydraulics. And I won't get into all the details here as to why that's the case, but the bottom line is the amount of diesel fuel you're using to run the pumps is a direct indicator of how efficiently you're actually drilling in the operation. And to my knowledge, that's never been published anywhere.
That's really cool.
And that has some important kind of side considerations, perhaps. So.
Well, on a more personal note, how did you get involved in hydraulics?
How did I get involved in hydraulics? A couple of pretty major answers to that. One is I had the privilege of having Dr. Leon Robinson, who many of you have heard of. Some of you may have even taken courses from him over the years. He traveled worldwide doing drilling courses, both when he worked at Exxon and then after he retired for about 30 years. Dr. Robinson was one of my mentors. He was my biggest mentor. And even after I left Exxon, he remained a mentor for probably 30 years after that. He had a passion for hydraulics that, being my mentor, spread over into me learning about hydraulics. And then after I kind of took on this technical field that I really enjoyed learning about, the boss of Leon and myself came to me and said, "Mark, we want you to teach hydraulics as a subject matter expert in the Exxon drilling school." And back then, that was one of these multi-week schools that went into great detail on every aspects of drilling. You don't see that type of school so much around today. But in the course of learning even more in order to teach that course, that's when it really turned into just a passionate technical hobby for me.
Well, very good. Well, have you ever been able to determine if the recommendations in the book can actually make a rig run more efficiently?
We have, and going back to the example I gave you of having a rig that was instrumented so that we could measure the amount of diesel. We had a case where, in fact, maybe we'll put the graphic up at this point. We had a case where I went on vacation, and the rig that I was the engineer on knew I paid attention to hydraulics, but my knowledge of hydraulics had not transferred to them yet, so they weren't comfortable sizing their own jet nozzles. And so while I was on vacation, one of the longest vacations I've ever taken in my life, to this day, the nozzle sizes they were putting in the well after bits kept getting larger and larger and larger. For those of you that are not familiar with bit nozzles, I've got an example here. Sometimes they have threads on the outside like this one does, other times they don't. Different bit manufacturers do them different ways. But what's important is this tungsten carbide insert, which doesn't wear out. It's tungsten carbide, has a very tiny hole in it. This is a number 10 or a number 11 nozzle, meaning 10 32nds of an inch or 11 32nds of an inch. It's smaller than your end of your little finger. That's probably a pretty good size to put in most bits and most applications. If you get much larger than that, what that means is there's less pressure drop at the bit. And that's okay if you engineer it and intend to do that. But if that was not your intent, then changing these nozzles can have a very deleterious effect on the overall efficiency of your hydraulic system. And when I got back from vacation, you can see on the chart, if you're looking at the red bars, that they were trying to make the nozzle smaller and smaller because they had gone all the way up to 16 or 18 32nds of an inch. Well, What I didn't tell you the chart axes are is the vertical axis is how much diesel is being burned by that rig in order to run the pumps. And so you can see when they knew I was about to come back from vacation, they started pinching the nozzles back just a little bit, but they were still 16 30-seconds or half an inch diameter, considerably larger than the one I just showed you. They were still way up larger than they should have been. So at the time, engineers were essentially consultants to the rig site operations, the way Exxon was structured. I could not order them to put the right nozzle size in there. It just wasn't how we were structured. But I recommended to them, and they chose to do something in between the 16 30-seconds that they were running and the 11 30-seconds that I recommended. And the blue bars show the sudden drop in diesel fuel usage when they put in, I think it was 13s or something, somewhere in between, if I remember right. They liked what that did. They didn't slow down drilling. They were burning less diesel by about 600 gallons a day at that point. They let me go ahead and put 11s in on the next bit run. And at that point, it dropped another 500 or so gallons of diesel per day for a net savings between unoptimized and optimized of being about 1,000, 1,100 gallons of diesel a day. Now, I'm not going to get real excited when you look at the overall cost of a drilling operation on saving 1,000 or 1,100 gallons of diesel per day. But I would note that this was a small land rig, and we have much bigger rigs drilling much deeper today, so that savings today would probably be a lot more. The other thing, to the drilling contractors that are listening to this podcast, I mean, it is the International Association of Drilling Contractors, is the best way to gauge whether or not a piece of machinery needs to be serviced or maintained or parts replaced is to measure the amount of work done by that piece of equipment, whether it's a generator, whether it's a prime mover moving that generator. And you do that by measuring the diesel burned by the prime movers. And so if you're saving over half of your diesel fuel usage, that translates directly into doubling the lifetime of your pumps. And that's a win-win for everybody, and nobody should be afraid to do that. And you're drilling more efficiently. So, why not do it?
That's a win-win-win situation.
Truly, win-win, 3 wins. Yes.
Well, on a different topic, with all the media and government attention on greenhouse gas emissions, can optimized hydraulics actually assist in maybe minimizing emissions?
It actually can, Fred, and by a surprisingly large amount. I've done several what we might call back-of-the-envelope calculations on this, based again on some of these diesel fuel measurements we made on previous rigs. And it turns out if you could optimize hydraulics on the worldwide rig fleet, now remember, we were talking about 1,000 or 1,100 gallons per day on a small land rig. Okay. If you multiply that by the number of rigs in the world and by 365 days a year, and by the fact that for every gallon of diesel burned, we get about 22.4 pounds of CO2 produced. If you ripple all of those savings through on an annual basis, it turns out to be about 3 million metric tons of CO2 would be saved if every rig in the world were optimized. Just a simple thing of optimizing hydraulics. To put that in perspective, the current savings of all the electric vehicles in North America is in that same ballpark number, about 3 million metric tons a year. So just by optimizing hydraulics, we could save as much CO2 as all the electric vehicles on the road today.
That's amazing.
That is
Yes.
amazing. It was very surprising, and we didn't realize that till after the book was actually written. So, but we do have the plot that you see on the screen, perhaps. We do have the plot in the book.
Okay. So have you seen cases where rig site personnel who may not understand hydraulics well have not used the principles in your book? And if so, what typically happens?
Yes, unfortunately I have, and the industry's getting much better educated since Dr. Robinson's been trying to teach people, and myself following in his footsteps. But what has happened is we still have a lot of turnover in rig site personnel, and a lot of those newer personnel do not understand the principles. So let's take our case where we have a bit that a directional coordinator has had nozzles put in, and let's say, just to stay consistent, that they're 11/32, like we were talking about earlier, and we have somebody that's afraid that just looks too small. Remember, that was smaller than the end of your finger. And they just think that looks too small. They have a natural tendency to increase the size of those nozzles, and they may tell, they're the boss on location, they may tell rig site personnel to take those nozzles out that have already been engineered to the right size and put something larger in. And when they do that, what's happening, and perhaps we can get another slide on this, but what's happening is your pressure drop across the bit then decreases fairly substantially. And if I go back to my example from before, again, to be consistent, where the 16s instead of 11s, turns out the way the equations work, if you go from 11/32 nozzles to 16/32 nozzles, you basically have doubled the total cross-sectional flow area because it's a squared term, but because of the way the bit pressure drop equation works, as a square of velocity on top of that, what happens is the bit pressure drop doesn't drop by half, it drops by a factor of 4. And so when you get on bottom with these larger, non-properly sized nozzles, what happens is you run your pumps up to the desired rate, and you don't have anywhere near the standpipe pressure you were expecting. And so what's going to then happen is those people on location who are used to seeing a high standpipe pressure, they're going to say, run the pumps faster. And as you run the pump faster, what that mostly does is increases the wasted diesel that gets burned. And they do come up to standpipe pressure, but very little of that goes across the drill bit where it can actually benefit the drilling operation.
And longevity of the pumps also decreases.
Great point.
Yeah.
Longevity decreases, the bit's not drilling as efficiently, and you might even be on the upper limits of your MWD type tools, and that may result in them wearing out even faster.
Now that's called a lose-lose-lose.
Yeah, that would be. That's a good way to phrase it.
So has writing the book had any unforeseen circumstances or consequences, perhaps even unrelated to the oil patch?
First, I've never written a book before, so it was quite an experience that was unforeseen. I never imagined the amount of time that it would take to write a technical, peer-reviewed book. Never done that before. But there were some spinoffs. I did get to teach some master's level courses overseas for a country that had a brand new developing oil and gas industry, and they had no courses in country to address that. The other thing that's very curious is in writing the book, I referred to some work done early, 120 years ago, by some gentlemen that were mainly trying to understand municipal water supply systems of all things. And we even have some of their original work as appendices in this book. And it turns out that just recently, a couple of years, 3 years after the book published, it turns out I've been now placed in a leadership position over, of all things, a municipal water supply system. So it's kind of what goes around comes around.
Exactly. Yeah. Well, that's really cool. So what's next for you?
Oh, I'm not sure, Fred. I gave up long ago trying to plan my own life. It's kind of what does the good Lord have in the store for me? I try to be open for new opportunities when doors open to walk through them, and if they close, then you don't walk through them.
That's a wise approach.
And I've learned that the hard way, actually.
And any acknowledgments that you'd like to make?
Well, yes, basically three in particular of individuals, and that actually starts off with you, Fred, because you were one of the inspirations, along with Dr. Robinson, for keeping working on this book for so long and doing some very valuable peer review on the book. And so that's two of the individuals. The third would be Juan Garcia. And those of you that don't know Juan Garcia, he's a former vice president of worldwide drilling, I believe it was, when he was retired from Exxon. And he was one of my early Exxon bosses before he was vice president of Exxon. And he also offered tremendous help in writing the book and peer reviewing it in great detail, offering many suggestions. And then I could not leave out the support that the IADC itself has given to this entire committee over the years. I've only been on it about 15 years or so, but
still a long time.
It's still a long time, but there's other people that have been basically collecting knowledge to spread to our great industry. It is a great industry, by the way. Our industry brings more good to mankind, frankly, than any industry in the world, and that's my honest to goodness opinion.
I really appreciate you saying that.
Well, I really believe that, and I've traveled the world. I've worked on 6 continents, as many of us on the committee have, and there's no business or industry out there that has brought more tangible resources to the world than the oil and gas industry.
Well, Mark, thank you very much for taking the time.
My pleasure.
To talk to us about this groundbreaking book.
And if you have any questions, email me, and I will answer email.
And Mark, what is your email address?
My email address for any questions you might have on the book, big or small, is Mark Ramsey, that's MarkRamsey, at Texas Drilling Associates, with an S at the end, all one word again, .com.
Very good. Now you too can get your own copy of Practical Wellbore Hydraulics and Hole Cleaning. It's available from many distributors, including Science Direct, that's Elsevier really, TechStreet, and Amazon. So go out and get your own copy.
And you can get electronic copies if you'd prefer, and those of you that may only be interested in, say, bit hydraulics, Elsevier, which, by the way, Fred, Elsevier is the prime technical book publisher in the entire world.
I know it.
They've been amazing to work with.
Yes.
But you can also purchase chapter by chapter of this particular book. You don't actually have to purchase the whole thing.
That's a good point.
If you're only interested in, say, sizing bit nozzles, you can just get that chapter.
And I like bit nozzles. So, yeah, that's the chapter that I would buy.
Yeah, there you go.